Hi, everyone. How are you doing? Check out the lab and we'll start in a few minutes. So this is going to be the last lab that we're going to do together. Next week on Thursday, we are going to have the holiday, which is Veterans Day. So we're not going to have a lab next week, but we're going to still do the assignment, and there will be a discussion thread for automata. Okay. Okay, so get your IDE ready. I also posted a Tesla internship opportunity in case you're interested. You can check that out. And there are various workshops that's being done. Hold on 1 second. Let me find some information. Okay, so if you're interested in doing some workshop, Nikki has sent me on the 10th of November, there's a job searching using a tool that we just acquired called Job Speaker. And that one is going to be at 12:50 during the college hour. Okay, I'll add this to the announcement later today. And then on the 15th, there's mental health career for the mental health career for the human services students. And then LinkedIn profile workshop in December. Okay, so check out the announcement that I had posted on Tesla if you want to apply for that one. They have internship opening. Okay, 6 o'clock, so we'll get started. This is gonna be the last lab. You made it, right? We're gonna not do any more lab after this. Next week, there is a holiday on Thursday. So we are gonna observe Veterans Day. No class will be in session. You are gonna be doing the assignment with me on Tuesday for the last chapter that we're gonna cover, or the last 2 chapters we're gonna cover. And then we are going to do a discussion thread with the automata. Okay, so that's going to allow you to expand a little bit more knowledge in different type of automaton. So this week we're going to do lab 11. And in this lab, we're going to cover cryptography, mainly Cipher. So you can see how it's done. So as we talked about on Tuesday, this is a way that we can apply modular arithmetic to our algorithm. And as we know that we would use mod 26 because there are 26 characters in the English alphabet, each of the character that's in plain text is going to be represented as X. And then we are going to add the shift, which is the placement for either shift. When we go to the right, that will be plus N. When we decrypt, we're going to subtract the shift. So that will be a numerical value, right? If we do a shift 7, then N will be 7. If we're going to do shift left, we're going to minus 7. So here it gives you the illustration on how each of the letter will be shifted. And let's take a look at example 1 program. Okay, so we typically just have the IO stream for C in, C out using namespace std. We have a function called encrypt, and its parameter would be string text that will be hard-coded. That's the string that we're going to declare in the main. And for our shift, the key is going to be S. Now we wanted to have string result store the encrypted text. So that will be in the string, and we have a for loop. So this is an iterative approach. So as we would implement the for loop, we're going to start with the first index, which is index 0. We're going to go to the end of that text length, and we're going to increment each of the characters. So string is an array of characters. So we're just going to iterate through each of the character. Now in the second part here, it says that for the statement if, we are going to use the isUpper method to convert your text. So if it is upper for each of the character, then we are going to take each of the character and we are going to add it with the shift, and we're going to subtract it with 65. Why 65, right? We saw the ASCII table, so you can pull up your ASCII table. And we're going to take a look at the ASCII table. So if you look at the uppercase A, that starts with 65 as a decimal value. So that's why we are subtracting 65. Then we're going to mod 26, and then we're going to plus 65. So that 65 just represent the uppercase A, the letter A. Else, we're going to have our result, because if it's lowercase, then we're going to subtract 97 and then mod 26 and then add it with 97. So that's going to allow it to implement the encoding value for the lowercase a. And the 65, that will be the uppercase A. So you wanted to also assume that the user might use upper and lowercase, and that's how we're going to be able to treat upper lowercase. Now, if you only implement 65, then you just have to force the string to be uppercase. So you would then have to take that string, right, and then use a built-in function, which is isUpper, convert it to isUpper, store it into another string or update that string, and then be able to operate the shift using just 65. Okay, so this is how we're going to handle upper and lowercase. And we're going to return the result. And in the main, we are going to declare our text, which is in plain text. And it's going to be attack at once, all uppercase, no space. And in this one, let me double check on yours to see. Yep. It's going to shift 4. So we are going to go right 4 space 4 letters to do the encryption. And then we're going to go left 4 letters to do the decryption. And we want to output. So we're going to display our text. And we're going to display the shift value. And we're going to display the encrypt text to show that it's shifted. So as we can see here, attack at once is going to be EXX, EGO, EX, SRGI as encrypt text. If we shift 4 characters. Okay. So we can set that up and run it in the IDE. Let me zoom in on my document here. So in the main, we already saw what S is initialized as. S is initialized as 4. So we would know that it is shifting 4. So in number 1, after we run the program, we can answer the question. How many characters are shifted in this program to cipher this text string? So that will be the value for int S, your variable S, and that is, it's going to shift 4 characters. And just like what we've done on Tuesday, we are going to double check by using the manual shifting with our alphabet, A through Z. So we simply take the string in plain text and we're going to manually shift to see the output is correct. So the A is going to be, if we count 4 places, 1, 2, 3, 4, that's going to land on E. The T, if we count 4 places, that's going to land on X. So the T and the T is going to be XX. And we have an A again. We already solved for that. So we put an E. And then for the C, that's going to be the G. So we put G. K is going to shift 4 places. So that will be O. And then A again. So that's E. And then T again. So that's X. And for O, we're going to count 4 places. That's going to give us S. And then N is going to give us R. So put R. C is going to land on, when we shift, that's going to go to G. And then lastly, your E is going to shift to I. So this is the outcome from the shift. And we would see, we would validate that it matches. Okay. Like I said, the program is as accurate as its programmer. So always wanted to manually check it. We can check it with the manual shift. It should be shifting. It should be outputting the same. Okay, so now let's try it with the different shift value where we would initialize S as a different value. And you can also edit your plain text string. You put your name or something, a phrase that you like. And when I test the encryption program, especially when students submit it, I like to see if it works with space or symbol. So we can say, hello. Let's try it with upper lowercase and see if the exclamation point actually works. And then we can do like a shift 8. So as you can see in this particular program, right, upper and lowercase works. And then if we check with the exclamation point, right, if you want to be sure, you can go to your ASCII table, look for the exclamation point. So the decimal value is 33. If it goes down 4, or I'm sorry, 8, 1, 2, 3, 4, 5, 6, 7, 8, it should have been this, the parentheses, but it's giving me this right here. Okay. So character still needs improvement in this particular program. Symbols, I mean. So all you want to do is you wanted to test, and that's going to tell me about the limitation of the program as well. So when you do your project, right, you wanted to see if, you know, space, characters are going to present a limitation, and then find ways to really look at the scope of how you're going to be able to manage that. Okay. Any question? So in this program, it's pretty simple. We have a function. In the function, we use a for loop to go through each of the character, and then we are going to implement the shift and the mod 26, and we want to apply the encoding. So we want to put in the encoding values. Okay. And then that's how we will be able to handle upper lowercase. Then we have the main, in which the main is where we would declare our plain text, and then our shift values, and then we would have the CL. So after you test it with a different string and a shift value, you can put down the answer. What shift value did you use? What kind of plain text string did you use? And what was the output? So then we want to identify the section of the code that would be the algorithm, and that's easy. You can simply look at the function and give me a brief explanation of what that function is doing, and I've gone over that. Any question? So realistically, we would have a program where the user would input, right? And now keep in mind that when you have user input, you want to think about like how you want to control that. So we want to implement input validation. Okay, and we want to be very clear about the instructions. So when you write this into your project, even though you're doing Visioneer, it's very similar to Caesar, you need to be clear about how you want your user to enter the information. And then you also want to think about how you want to input validate. Okay. Any concern or question from one before we move to number two?
Hi, Professor. I just had a really quick question on
Yep.
the on the is upper part on the tail end of the, the formula. I get the mod 26 because it's the 26 characters, but we're adding 65. That's the capital letter. I guess I'm.
Yeah. So the compiler it uses so application uses a different type of encoding to represent text, right? Sometimes it could be ASCII, other times it will be like UTF-8 and so on. So there are different type of encoding. So what it's doing, the computer understands everything as a number, okay? So the 65 comes from the ASCII table, and the compiler uses ASCII to convert text to a value. So it's a way that we would encode each of the character to represent that character as a number. Okay. So so capital A is going to be 65 in decimal. And as we're using integer, right, that's a decimal value. So when you declare int in the program, you have to apply the 65 because that way it would know that that will be an uppercase. Because how can we distinguish between an uppercase and a lowercase? And the computer distinguish it by using different values, right? So when you type a capital A, it would seize it as a 65 decimal or convert it into binary. And then if you type a lowercase a, it would see it as a 97 decimal. So with
that's
that,
the if and else. I see it. Okay.
Yeah. And why are we adding and subtracting? Because if you're only adding it, right, it offsets it by 65, but then you have to subtract it to reduce the offset. But you have to tell it what that represent, upper or lowercase. So that's a way that we can distinguish between upper and lowercase, or at least the system will, and we tell it how.
Got it. Thank you.
Yeah. Now, I've had project that turn into mean that only uses uppercase. So no matter what you type, it converts it to uppercase, right? Because they only wanted to implement the 65 instead of, the 97. It's just a few more lines, but that's how they approach it. So in that case, like if you have a user input, you would use the is upper, you force it to be an uppercase, right? Make it a string and then use that string and then apply it. So you can loop that new string once it's converted. Okay, so this is one approach. You're going to see different approach into how doing Caesar. Okay, other questions? Okay, so the good thing is that the computer can compute with number, and the computer would also compute with letters, because letters to it is just a number, right? So in the example 2, you're going to see that instead of using a numerical value for ASCII, we're just going to use the letters. Okay. All right, let me open up my example 2. So this one is doesn't have any separate function or anything. So if I was to improve this, I would write multiple functions and then use the main to call the functions or a function to call function, right? But everything is in the main. And we would assume that the user would put in a lot of a long string, right? And in this case, we're going to have an array of 100 characters, a string array of 100 characters. Okay. Now, when you do your project, you don't have to use char. You can use string object. So you can think about how you would approach it with the string object. But char is like the easiest because it just shifted based on the character. So for Caesar cipher, it's simple because we know we just move the letters like down the line, right? So it's easy to implement with char. But for Vigenère, you don't have to. You can use char, but you can also use string object. I've seen either example or also student project turn in using string. Okay, so here we are. We have the main. We have an array that's going to be our message array. It's going to store up to 100 characters. Okay, and we declare ch as a variable for each of the character. And then we have int I and int key. So this is going to be our shift is the key and I is for index. Then we want to prompt the user as this one is going to record user input. We're going to prompt the user enter a message to encrypt. And it's going to use the getLine function to record the input. And it's going to store it into the message array. And then it's going to ask the user to enter the shift value. Then it's going to store it into the key. So using this approach in your project, you can think about, okay, so I can prompt the user to enter a plain text string, and then I would ask them to enter a key, but instead of a value, its key, we would then have it as a string key or char array as key, right? Then we would have a loop, a for loop. We're going to start with the first character, right? And in this one, it's a little different so the index, if it's not going to be, right, if it's not, it's going to go to the end before the null terminated. So you know that all the string, the last space for that is going to be the null termination. That's the end of the string, right? So it says that if the message index is not null terminated, it's going to keep increment. So all that means is it's just going to go to the end of that array of char. Okay, just another way to write it. Then our CH is going to store each of the character in our message array as it loops. Then we want to nest the if. So now we can apply the conditions. If the char is greater than equal to a lowercase, and if the char is less than and equal to z, right? Because our alphabet is going to be from A to Z, right? So it's going to be greater than A, B is greater than A, C is greater than A, and it's going to go up to Z. And so if that's the case, we're going to take each of the character and we're going to add the shift to it. So we're going to add the value for the key. So when the computer, when it sees this, it's going to take that letter, right, and see the equivalence of that. So in the back, it's still going to apply the numerical value anyway. Okay. So it's going to take that, it's going to add the key. Now, when it is greater than Z, right? So what's greater than Z? if you're looking at ASCII, well, these are greater than Z. The curly brace, the pipe, the till. Okay. The ceiling for this, right, is going to be 127, but you have additional symbol that might belong to other alphabets up here, right? So for example, like in Spanish, when you write a questions, upside down question marks, right? So these are greater than Z, additional symbols. Okay. So then, it's going to take the character and it's going to subtract the equivalent value of Z plus the A minus 1. Okay. So if you think about that, if you're looking at ASCII, Z is lowercase z is here. Where is it? 122. Okay. So then what I'm going to do is if I have a value for my character like I or something like that, I'm going to subtract Z and then I'm going to plus the A, because remember that we're still, when you represent the alphabet, when you ship at the end of Z, you come back to the beginning, which is A, right? Okay, and then we're going to do a minus 1. Why are we minusing 1? Anyone know? Nobody knows? Oh. Nobody knows why we're minusing 1. Remember what I said about this? Okay, so when we take the character, subtract Z plus the A, we're going to come back to the beginning. But remember, in the string, it's also null terminated. So it's going to be 1 space less. That's going to be minus 1. Then your message index is going to be the, each of the index is going to be stored in CH. Then you have an else if. Now we're going to handle the upper. So just like what you did with the lowercase here, you're just going to use the uppercase letter. You are going to encrypt. So you're going to add the key. And then the same thing as before, you're going to take the character minus the uppercase Z plus the A, because you have to come back to the beginning of the alphabet at the end, and then subtract 1. Then you are going to have each of the index stored in CH. Then you're going to output your encrypted message is stored in message, right, which is an array. So when we run this, it's just going to prompt. So if we do attack at once, okay, and then if we do a 4, we want to test the other program now, right? Same. It's still going to output what we saw from example 1. Okay. Now if we can test it with lowercase and the uppercase. We're going to shift 4, and it handles that just fine. Okay, so it gives you the uppercase E for the uppercase A. Okay, so put this program into your IDE, run it. Now we're going to the test, right? We are Klingons. Okay, I chose this for a reason. You see. Okay, so let's rerun this. Did I put it all uppercase? No. And we want to shift 13. We're going to do a rotation 13 on this one. Okay, so when we test it with We Are Klingons, it handles the uppercase W fine. That gives us a J. And everything else fine. The capital K gives us an X. That's good. That's good. But wait, what happens to the S at the end, right? It's giving me some kind of symbol. It doesn't really show me exactly what that is. It's so small. So let's go back to the ASCII table. If you're looking at the letter S, that's already 115, okay? Now, if we add 13 to it, it's 128. So it's at the end of this. So going to 128, look at what it does. So it's supposed to give me this symbol, but the compiler, it doesn't know what that is. So it just gives me that whatever symbol that it can come up with to represent 128 decimal as a symbol. Okay. So it's a character. It's just not an alphabet character. Okay. So as you can see why, because if you take 115 plus 13, gives you 128 and it's a symbol. Okay, so if we verify this, right? If we do, we are Klingon. So if we count W, we come back to the beginning. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There should be a J. And so on. But let's look at the S individually, right? It should be matching to what the program output, except for the last character. Because the S, ideally, we should come back to the beginning. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That should be F, right? But it didn't do that. So the downfall in this program is that when you do it like this, right, instead of coming back to the beginning of the alphabet for the later letters, it actually extended to the rest of the symbol. So when we compare the first example to this example, right, the difference in that we would see that in the first program, we also implemented a loop, we also implemented a condition, but we're using the decimal equivalents of the upper and the lowercase letter in our conditions. That's nested in the loop. And we would be able to control the upper and the lowercase. Now in this one, we're using the letter. And also one of the main difference when you are increasing your shift value, right? It's going to extend that to the symbol. So for 2C, I just want you to give me an overall perspective for the comparison between 2 and 1, explain the differences between the program, how they approach, right, the algorithm itself. Any question on number 2? Okay. No question on 2. Now what we're going to do is we are going to look at how we would decrypt. And as you've seen in the example 2, example 3 is going to be very close to that, but we're going to subtract the key to decrypt. So in this one, just like the other one, we have a main function. We have an array that has, that is a message array that can store up to 100 characters. We have a variable called ch that's going to store each of the character as we loop. And we have int I to represent the index. And our key is going to be the shift left value to decrypt. Then it's going to prompt the user to enter a plain text message. And then using getLine to record that into the message array up to 100 characters. Then it's going to ask the user to input the shift value. And we are going to store that into the key. Same as before, we're going to have a for loop that's going to start from the first character. That's going to loop all the way to the end. If it's not null terminated, then it's going to continue. And then each time that it loops, the CH is going to be each of the index for each of the character. In the if statement, just like before, when it's greater and equal to A, right, we wanted the condition to be that the character is greater and equal to A, and if the character is less than and equal to Z, lowercase. Then we are going to take the character, subtract the key. If the character is greater than A, then we are going to take each of the character, we're going to add it to the lowercase z minus A, and then we're going to do a +1. And then here again, we're going to have the CH is going to be each of the character in the message array. For the else if statement, we are going to apply this to the uppercase letters, the uppercase A and the Z, just like how we did with the lowercase. And again, we're going to take each of the character and subtract the key because we're decrypting. And we're going to do the same thing with the nested if, with the uppercase A. If the character is greater than A, then it's going to do take that character plus the capital Z and subtract A minus CH +1. So then it's going to give us the decryption. Now, let's see if we run this and we test the Klingon message, right? Let's see if I can paste it. And then I'm going to do a rotation 13. Guess what happens? It didn't work. Because on the higher shift, right, when we shift left this time, taking this, so the boundary for this program is problematic. Okay? The boundary for the program is problematic. So when we test it with the rotation 13 with, right, the encrypted. So this should take me back to we are Klingons from earlier, right? Going the opposite way. But it gives me AX symbol, T symbol, UT symbol. Now let's see if it works with the first program. Okay. I'm gonna go and grab this shift 4 that we did. Sorry, let me double check. I think I had something change on my, hold on 1 second. Yeah, I don't know why this is here. Sorry. Let's fix that. Let's try again. Stop. Q4. What do you think we're lacking here, you think? Anyone know? So remember that this, by subtracting the shift and putting in the range for the character is not enough, right? So the boundary for that is wrong in that what happens to the alphabet, right? Like if we are only using A through Z, that needs to be represented with modular arithmetic. Okay, that's the downfall for this. All right, so now you can see. Okay. So for A, you can just put in, you don't have to put this in, you can put in any of the encrypted characters and then try to test it with the shift, as what I've done with the rotation 13 from the last exercise and the exercise before to see if it works, right? The functionality of this program, there's limitation in that it doesn't really handle some of the shift correctly. It doesn't handle the range of your alphabet correctly. So you can explain the actual functionality that they implement here, but you know, room for improvement there. So to approach this, okay, I would use the example 1 because that will be a little bit more solid. And then when you're going in reverse, you just have to subtract the key instead of just adding the key for the encrypt. All right, question. So test the program I'm going to highlight this so I can fix it for the next class. And then explain the functionality of the decryption. Compare the program to the encryption program in exercise 2. What are the primary differences and similarities? We can say that to decrypt, we simply subtract the key. To encrypt, we add the key, right? The similarities in this program is that, you know, the boundaries for the program is basically, you know, it needs improvement, right? It needs to be corrected to be able to handle the range of your alphabet. So because as it shifts now, when you're including all of the symbols, it's not limiting to 26 characters anymore. It's actually expanding to the rest, which creates a problem because in Caesar Cipher, if we want to do the range for only the characters, then it should only be 26 characters. Okay. Now you can increase the range to be higher, but you just have to think about how you would control that range, you know, beyond your Z or your lowercase z. Okay. Any question with 3? All right. Next, we're going to do string for encryption. So my intention for this is to present to you different type of solutions for the same type of problem, right? Which is Caesar Cipher. Now, not all the solutions are accurate, or sometimes it works, but then there's limitation to the solution. And we have to be mindful of that on how we would be able to program a solution. And looking at what will be the limitations in our program. Okay. Okay. Only have a couple more to go and then we'll be done. So in the next example, which is example 4, we're going to use string object. So we're going to include string. And we have a function called encrypt. And this is the prototype of the function. So it's going to use string and integers as data type for parameter for arguments. In the main, right, we are going to have the 2 functions. One is going to be the source. The second is going to be encrypt. So here is where we define. Okay. Then for the source, we're going to have the variable key. We are going to output the message, input message so the user can enter their text. Use a get line, store that. Okay. Then we are going to prompt the user to enter the shift key and put that into key. Then on the next line here, that's just to display the encrypted text. And in that, we would call the encrypt function, right? So in this one, it's going to call the source. Okay, so a function calling a function. Then we are, for the definition for the encrypt, we would have the crypted variable defined as source. Then we are going to have a for loop. It's going to start at the first index, go to the end of that string, and then update as we go for each of the character, because string is an array of character that's no terminated. And then we simply is gonna add each of the character with the key value. And we're gonna return encrypted. So as that function is called, so we can say attack at once, and we're gonna shift 4. So that works. Let's see if it handles lowercase. That works. See if it handles a symbol. And let's see if it handles space. Okay. So then, when you enter that program, you can test it with a string, and then you can test it with the shift value. So substitution and then shift 5 places. We can do that. Then we wanted to take a look at the program and then be able to identify the functionality of the program, the primary functionality. And we want to explain how the shift cipher is integrated. So the area that we want to look at would be, right, the encrypt function here, and then how that would relate to the input. So this is just going to be for the input section, right, your source, and then it's going to store that into source as an input, and then you are going to use the function encrypt to really encrypt, right? And it just implemented a for loop. So as you can see, when we go from char to string, right, for the character, you have to either think about how you will implement, you know, upper lower case because they are different. But for the string, it was treated like one entity, right? Even though it is an array of character and we still loop through it, but it's already automatically converted. So we don't need to really think about how we would implement like the 65 and the 97 when you're using string. Now, just like the other programs, you wanted to check out its limitation, right? Like you wanted to test it to see how it handles space, symbols, um, you know, things like that. Is it accurate? And you know how to manually shift so you can see if it's accurate or not. Because the majority of the times, right, if it's shift right, but then when it can't handle some of the other type of characters outside of your alphabet characters, then we have to think about how we can expand the program to be able to deal with that. So it will be complete. So after you have explained the functionality of your program from that function for B, then you want to compare that program to example 1 and 2. What are the differences and similarities in the shift for the cipher? Well, the other two, you saw that we use char as a data type, and then in this one, we type it as string. And we imported, or we include the string library or the string STL. While we're using the for loop, which is the same, right? But we didn't have, we just simply add the key, which is similar to what you kind of see in the other one, the second one. But so as we take each of the current character, then we're just gonna do we're gonna add the key to it. So when you compare those, how accurate are they, right? From this one to the other ones, do you think it's more efficient? Space and time. Okay. Any questions? I don't know why I have these extra spaces here. Okay. No question on 4. All right. So for the next one, which is number 5, in this one, we're also going to include string. And we are going to prototype a function called Caesar. It's going to use char. In the main, we are going to implement the input, which includes a do while statement. So it's always going to prompt enter the ciphertext and press enter to continue, right? And then enter the blank line to quit. It's going to store the input. And then for the variable output, that's going to be our encrypted text. Then we are going to have a for loop, starting with the first character, go all the way to the end, the entire length of the input. Your output is going to be, it's going to call in Caesar here, which is our function. We later define that. So we are going to execute the function for each of the input, or each character of the input. And then we're going to display. The while portion is to verify that it is not 0. So they have to enter some kind of characters for it to encrypt. Then for the function itself, we wanted to validate that. So the if statement here, we're going to check to see if it's alphabetic for each of the character. Then we're going to force it to be uppercase. So to upper. And then we would apply the encoding numerical value for lowercase a, or I'm sorry, uppercase a, which is 65. And then we mod it by 26 because it's A through Z. And we're going to add it with 65. And then we're going to return it. So first, we are going to type in our text. I think I have to do characters. Okay. And it's always going to prompt. So we can do characters, lowercase. So our output is always going to be the uppercase as we have it to upper here. So do we know the shift value? Right? So when you look at the code, right, the shift value is added there, which is 13. Okay, so for question A, 5A, it says, what is the shift value? We should see that here. That's implemented in the function Caesar. C minus 65, that's represent the uppercase A, plus the key, the shift, which is 13, mod 26 plus 65. So our shift is 13. It's an ROT 13, right? Then there's a program encrypt the symbol of special character, so we can test it. Let's see. No, it does not encrypt symbols because symbols are just symbols to it. What about space? So space is a space, symbol is symbols. Okay, so then After we answer A, we test it with characters. Is it accurate? Just verify to see if it's correct. And you can check to also and remember that this is 13, right? Or we can do so it's encrypted fine. Challenge with it is that a space is still a space. If you wanted to keep it as a space, that's fine, unless you wanted to convert or encrypt a space, and symbols are still symbols. So a symbol should be encrypted because it is a character, right? So the mod 26 here is going to only range it to A through Z. And we're converting everything to uppercase. So we would describe the functionality of the shift for the encryption, explain how the shift cipher is integrated in the program, and then for D, we just kind of compare this program to example 4, which is previous. What are the differences and similarities in the shift cipher program? Evaluate these programs based on efficiency, performance, accuracy, and complexity. So we do see that, right? They both include string STL. They both prompt the user to input. This program convert everything to uppercase. This program uses mod 26, where it only ranges for A through Z, where the other one doesn't, right? And so on. So you can compare the differences. And you can state how accurate one over the other. Time went by so fast. I remember the first day I was just teaching you binaries and hexadecimal, and now we're almost at the end of the semester. So 5 more weeks before the classes end. Okay, any question on example 5 or exercise 5? Okay. All right, so that takes care of our week 11. Okay. You do have unit 12, which I haven't added the content for it. It's there, but it's just gonna be linked. I will add the video tonight for the lab, but on my playlist on the channel actually has last semester's. So after unit 12, you do have the last quiz. And in the upcoming week, so I like to go over the final review in week 13, unless I think I have it recorded last time, so it's on there, but there is a final review which I will release. Okay. So you have to also prepare for your final exam, which is multiple choice. And that's going to be in week 16. So I will give you time off to work on your project and so on, because I know that there are a lot of things going on all in the other classes too. So, but I am available in case you want me to answer some questions about your project or any concern, anything like that, subsequent to week 13 or subsequent to final review. Okay. On week 16, make sure that we turn in our course project. Don't forget, something is better than nothing. I'm going to tell you that now, right? And anything that you need to turn in, I will no longer take anything after. I'm going to tell you the cutoff date for late work, that is. Okay. So this week right here, the 5th, is going to be the last day that I'm going to take any kind of late work from the prior weeks. But you can, if there's something that's currently due, like the project, you can still turn that in. But any prior late work, because I want to finalize the grade and I wanted to get, you up to date with your grade going into the final exam. So you just have the only two things that will be graded is going to be heavily impacted, of course, is your project and your final. And I usually take a couple of days after the class ends, which is on the, I would say the 15th or the 16th, the 16th. Okay. Final exam is going to open starting the Monday, which is the 13th, and it's going to close on the 16th. So you do have a few days. It's going to close exactly at 11:59. And I do not take late project or late final exam, no exception. Okay. This is why I'm giving you 6 weeks to work on your project. So in the case where you need time, you need to prepare for that now. If you're taking a vacation for Christmas or early vacation, just gotta make sure that you get that done and then get it out of the way so you can enjoy your vacation. But so I don't do late final or late project. That's one of the things. I do take late work up until the 5th. Okay, any questions? All right. Let's stop recording.